Hello, my dear students. Good morning to everyone. So, in last last lecture, we discussed the weighted average of price relative method, and we have also discussed how quantity index has been constructed, or how quantity index are being constructed, and how we can construct the volume index. Okay. So the major difference between quantity index and price index is in price index we are measuring the changes in the price, whereas in the quantity index we are measuring the changes in the quantity of purchase or quantity of consumption. Okay, yes. So the only difference between these, the construction of these two indexes, wherever you put P in price index, where you will put Q in quantity index. That's the only difference. Okay. So today in this lecture or in this video, what I'm going to discuss with you is certain or some test of adequacy of index number formula. So in index number we have discussed a lot of uh, method, simple index number, simple aggregate index number, then simple average of price relative index number, weighted average of price relative index number. Okay, so a questions, so why we are having so many methods? Because in each and every method it has certain advantages of some other method. Okay, so each method has its own advantages over the other method. Okay, so even though there are large number of methods, but the most commonly used method are weighted index numbers, especially the last pair and the past year's index number. If you look at many indexes or many composite indexes in India, especially WPI, Consumer Price Index, and all, or and the index of industrial production, in all these, we are using either last pair method or past year's method. Okay, so in last lecture we have also discussed the problem with last pair index. Okay, similarly the problem with the past year's index. Last pair index is it has certain upward bias, oh sorry, downward bias. Okay, whereas this past year index is having some upward biased. Okay, so these two indexes are either biased to either direction, upward or a downward or upward directions. Okay, so because the main problem for the downward bias in last pair index is we are using the quantities in the base period as the uh, basis for weight. Okay, we are using Q0 as the weight. Okay, since the Q0 is the quantity of the previous purchase. Okay, and because we are using this as the weights, there must be an downward bias. Similarly, when we are using Q1 as the weight, okay, then there will be downward bias. Okay, so there are certain conditions for that, so we have discussed already. That's why I'm not going to discuss it. Okay, so the thing is that the question is which method is the best method, or which formula is the best formula which is free from bias to either direction. Okay, so this is the major fundamental questions. Okay, so in order to answer for this question, R.A. Fisher or Professor Fisher, he has given certain test. Okay, so Professor Fisher has given two tests. The first one is the time reversal test, and second one is the factor reversal test. So on the basis of these two tests of adequacy, we can find out which one is the best or ideal index number. Okay. Similarly, some statistician has suggested unit test, and another statistician suggested the circular test. Okay. So there are four different tests are available to check the adequacy or the goodness of this index number formula. Okay. First one is the unit test. Second one is the time reversal test. Third one is the factor reversal test, and fourth one is the circular test. Okay. So the most simplest test is the unit test. Okay. So unit test, the simplest thing is that the index number formula should be independent of the unit in which prices or quantities are quoted. So this is a very simple thing, that since we are comparing different commodities price and commodity quantities. Okay, these commodities are measured in different quantities or different measurements. Some commodities are measured in meter, some commodities are in liter, some in kilogram, some in gram. Okay, some in dozens, some in numbers. Okay, so since many commodities are measured in many different units of measurement, so this unit of measurement should not influence the index number calculations or the index number value. Okay, so this is the prices and quantities quoted should not be influence the index number formula or index number value. This is the most important and most almost all the formulas except simple aggregate prices or quantity index number satisfy this test. Okay, so this condition or this criteria is satisfied by all the index number except one. Okay, so that is simple aggregate price or simple aggregate quantity index number. This index number is not satisfying this test. Okay, yes. Coming to the next test, this is the most important test, time reversal test. Okay, so as the name indicates, time reversal test. What is that? This index number or this test is telling about time inconsistency of an index number. Okay, what is mean by time inconsistency? The index number should work both forward and backward with respect to time. Okay, the time consistency means the index number should be consistent between two different periods, forward or backward. We will explain you little more. Okay, so as per this test, suppose if you are considering any particular year as a base year, okay, and on the base of this base year, we will compute some other price index or some other period price index. Okay, then what we do is when the time subscripts are reversed, then the both price indices must be reciprocal to each other. Okay, that means, so suppose P01, what is that? P01 price index for the current year, keeping 0 as the base year. Okay, you reverse it. What is that? P10. What is it? Price index for the period base year, keeping current year as, sorry, 0, keeping 1 year, keeping 1 as the constant or base year. Okay, so if you what called, if you change 1 to 0 and 0 to 1, then both price index must be reciprocal to each other. I will give you what is this. P01 should be equal to 1 divided by P10, or you take P01, you multiply P10, you should get 1. Okay, so in this P01, what we are assuming is we are calculating the price index by considering 0 as base year. Here we are considering 1 as base. You change the subscripts. Okay, you change the time. Okay, in first case we will consider current year and base year. In the next time we will consider the earlier base period as the current period and the earlier current period as the base year. Then you multiply both equation and both values, you should get 1. That means the index number should be time inconsistent. Even if you change the time, it should not be vary. Okay, so this is the idea behind the time reversal test. And in this time reversal test, it is not satisfied by many index number. If you take last pair index number is not satisfying this time reversal test. And if you take past chase index number, it is also not satisfying the test. Okay, let me check it. Okay, so what is the equation of last pair index number? Sigma P1 Q0 divided by sigma P0 Q0. Okay, so ordinary an index number, the numerator will be the current price, denominator is base year price. So it will be sigma P1 divided by sigma P0. Then we will add the weight. Okay, so in last pair Q0 is the weight, so P1 Q0, P0 Q0. Okay, now what you're doing, this is what is called P01. Now here we have taken P1, so instead you change this 1 into 0. Okay, you see here 1 becomes 0, and here it is 0, 0 become 1. Okay, now here this is 0, this is 0, so both will become, this will become 1 and this also become 1. This is what is called changing the subscripts. Okay, 0 will become 1 and 1 will become 0. Okay, so 0 become 1 means what? Base year is becoming current year, and 1 is becoming 0, current year is considering as a base year. Okay, then you multiply this both equation, you will know, you should get 1. Okay, but here you look at this equation. In first equation, sigma P1 Q0 divided by sigma P0 Q0, and next equation sigma P0 Q1 and divided by sigma P0 Q1. So we cannot cancel out any of these part of these equations. Okay, and that's why we can say that it should not be equal to 1. Okay, so it's not equal to 1. Now you look at this past year's index number. What is the equation of past year's index number? P1 sigma P1 Q1. Look at this sigma P0 Q1. Okay, change the subscripts. P1 become P0, Q1 become Q0, P0 become P1, Q1 become Q0. Now you multiply this. In first, we will find out the equation of find out the P01, and next we'll find out P10. You multiply these two equations, you should get 1. If you are getting 1, then the time reversal test is satisfied. If you are not getting 1, then this test is not satisfied. Okay, that means in current year and base year, even if when we change this base year and current year each other, we are not getting the similar result. That is, this index number is not time consistent. Okay? Yes. Now, if you look at this third test, if you look at which are the tests that satisfy this time reversal test. Many tests are satisfying this test. The first one is the simple aggregate price index number, Walsh index number, Fisher index number, simple geometric mean of price relative index number, Kelly's index number, and Marshall Edgeworth index number. Okay, so these 6 index number formula are satisfying this time reversal test. Okay, now let me check one. Yeah, now let me check whether the simple aggregate price index number is satisfying this time reversal test. Okay, you take an equation. What is the equation of a simple aggregate price index number? Sigma P1 divided by sigma P0. Okay, now you change the subscript. That is, P1 convert into P0, P0 convert into P1. Okay, now you look at this P0, this P1 become P0, P0 become P1. Now you look at this equation, sigma P1 is here, sigma P1 is also here. Sigma P0 is here, here is also here. So it will be equal to x. We can easily cancel out these two equations. So it will be equal to 1. So what we can say, simple aggregate price index number satisfy time reversal test. Okay, coming to the next one, it's the most important test, Fisher index number. Okay, so what is the formula for Fisher index number? Fisher index number is nothing but the geometric average of last pair and past year's method. Okay, so what is last pair index number? Sigma P1 Q0 divided by sigma P0 Q0 into past is sigma P1 Q1 divided by sigma P0 Q1. Okay, so this is the last pair index, this is the past year's index. Okay, so you multiply to these equations. Now what you have to do is, what is this? We are changing the last pair index time. Okay, so it was P1 Q0, now P0 Q1. It was P0 Q0, now P1 Q1. Now P0 Q0, P1 Q1, P0 Q1, P1 Q0. 0 become 1 and 1 become 0. Okay, so here what we can do here, can we cancel out each and every equations, sorry, each components? Okay, so here if you look at sigma P1 Q0 and this will be cancelled out. Okay, then sigma P0 Q0 and this will be cancelled out. Okay, then this sigma P1 Q1 and this will be cancelled out. Okay, then sigma P0 Q1 and this will be cancelled out. Okay, so you will get root 1 will become 1. Okay, so you have to understand one thing, when you are doing this we are ignoring the 100. Okay, so in each index number what we are doing, we are multiplying with 100. Okay, that's what is called a correction factor. But when we are testing all these formula for adequacy, we will ignore this 100. Okay, yes. So what we can understand here, that Fisher index test, uh, Fisher index is satisfying time reversal test. Now you look at the Marshall-Edgeworth index. Okay, so this will be the equation. Okay, so this is the numerator for the last pair index. This is the numerator for the Fisher index. Sorry, past year's index. This is the denominator for last pair index. This is the denominator for past year's index. Okay, so Marshall and Edgeworth, what they are doing, they are taking the average weight, the arithmetic weight of Q0 and Q1 as the weight. Okay, so it will look like this, and if you change the subscript, 0 become 1 and 1 become 0. Okay, so if you multiply here also, we can cancel out each and every component in this equations, and finally what we will get, we will get 1. Okay, so in like Fisher equation also, like Fisher equation here, in Marshall and Edgeworth equation also, we can cancel out all these different components of this equation. Okay, yes, so we will get 1. Okay, so that's all about Fisher time reversal test. Okay, so coming to the factor reversal test. In factor reversal test is the other test or another test proposed by Fisher. Okay, so Fisher has suggested only two tests, time reversal and the factor reversal test. Okay, so coming to factor reversal test, the factor reversal test permit interchange of price and quantities without giving inconsistent result. Okay, so what is that? So in time reversal test, what we have done, we have changed 1 into 0 and 0 into 1. The result should be time inconsistent. Okay, here what we are going to do is, we will change P into Q and Q into P. Okay, and the result should be consistent. Earlier in time reversal test, we are changing the time component. Time component is what? 1 and 0. Okay, here in factor reversal test, we are changing the factor. That means we are changing, whenever there is P, we will replace this P with Q, and wherever there is Q, we will replace this Q with P. Okay, then what you have to get, if you multiply these two equations, okay, you should get the true value, or in equation, using equation you can say that F40, or that means factor reversal test is satisfied when P01 into Q01, that is price index multiplied by quantity index, should be equal to sigma P1 Q1 divided by sigma P0 Q0. What is the sigma P1 Q1 divided by sigma P0 Q0? It is nothing but value index number. Okay, so price index number multiplied by the quantity index number should be equal to the value index. Okay, so this is the condition, or this is the criteria. What is that? Earlier, what was the criteria in time reversal test? P01 into P10 should be equal to 1. Here P01 into Q01 is equal to V. What is this V? Value index. Okay, yes. But the thing is that this factor reversal test is only satisfied by the Fisher index number. None of the other index number is satisfying these conditions. Okay, so Fisher index number is the only index number that satisfy both time reversal test as well as factor reversal test. Okay, so let me check whether the simple aggregate index number is satisfying factor reversal test or not. Okay, look at this P01. What is P01? P1, sigma P1 divided by sigma P0. This is nothing but P01. Okay, then what is Q01? You change, this is P, make it as a Q, sigma Q1 divided by sigma Q0. Okay, then if you multiply this, you should get sigma P1 Q1 divided by sigma P0 Q0. Okay, But when you calculate this value, if you take a numerical value and if you calculate this and if you multiply this, you won't get it into sigma P1 Q1 divided by sigma P0 Q0. Okay? Yes. So look at this value. If you just simply look at this value, you may uh, first say that sigma P1 multiplied by sigma Q1 will be the same, okay? But sigma P1 and the sigma Q1, if you multiply sigma P1 into sigma Q1, you won't get sigma P1 Q1. Okay? Yes. So that we can check numerically using example later. Now you check the last pair index number, last pair and past chair index number. In last pair index number, this is the equation P sigma P1 Q0 divided by sigma P0 Q0. Okay. Then what is Q? Sigma Q1 P0 divided by sigma Q0 P0. That means wherever there is P, you put Q. Wherever there is Q, you put P. Okay. Then if you multiply these two, you are not getting this value. Sigma P1 Q0 into sigma Q1 P1. Okay, even if you multiply it, you won't get this sigma P1 Q1 divided sigma P0 Q. You won't get it. Okay. Similarly, if you do it for last past year's index number, here also you won't get these values. Or P01 into Q01 may not equal to value index number. Okay. So what you can understand from here? Symbol aggregate index number, last pair index number, or past year's index number, these tests are not satisfying. These index number are not satisfying this factor reversal test. Now we can check whether this Fisher index number, how Fisher index number is satisfying this factor reversal test. Okay, so P01. So this is the price index number of Fisher. Okay, this is last pair, this is past year. Okay, we are taking the geometric mean. Now you look here, this is the quantity index. Okay, I have changed P into Q and Q into P. It's become quantity index number. And if I multiply these two equations, what will get? Okay, so if I multiply these things, I can say that, okay, so many equation will be cancelled out. If you check it, sigma P1 Q0, sigma P1 Q0 is there, sigma P1 Q0 is also here. Okay, now if you check Q1 P0, yes, sigma Q1 P0, that's also we can cancel out. Now the remaining is sigma P1 Q1 is here and it is also here, P1 Q1 and P1 Q1. Here it is P0 Q0, here it is also P0 Q0, both are same. Q0 into P0, P0 into Q0, both are same. Okay, so what I'm going to take? I'm going to take square of it, P1 Q1 square divided by sigma P0 Q1 square. I'm taking sigma P1 square and sigma P0 Q1 square under root. Okay, now you remove the root. Okay, when you remove this root, these two exponents will go. Now what happened? It is simply become sigma P1 Q1 and sigma P0 Q0. It is a value index number. Okay, so Fisher index number is basically satisfying this time reversal test. Okay, and none of the other methods are not satisfying this test. Okay, and sometimes for a competitive examination, a special type of question arises. Okay, so I have told you that only Fisher index will satisfy the factor reversal test. Okay, But the last pair index number and past chase index number will be satisfied this factor reversal test when there is a condition met. Okay, so what is that condition? The condition is if your last pair index number and past chase index number are the same value. If your last pair index number and past chase index number are the same value, okay, then it will be, then the last pair as well as past chase both index number will satisfy the factor reversal test. Okay, so that this is the derivation for that. Okay, I'm not going to discuss it. It is a little bit mathematical. Those who are interested, you can learn it. Okay, so if a question arises like when this oh, when this factor reversal test is satisfied, or what are the test or what are the condition for satisfying factor reversal test for last pair index number and past index number. The condition is if last pair index number is exactly equal to the past chase index number, then it will produce or it will satisfy the factor reversal test. Okay, now we are moving into the last test. It is circular test. Okay, so the circular test is an extension of the time reversal test. Okay, so this is basically an extension of this uh, checking the time consistency between more than two period. Okay, so in if, time reversal test we have checked the time between two period base, one base period and one current period, 0 and 1. Okay, so this test which is suggested by Westergaard, he said that he the basic idea behind this method or this test is to check the time inconsistency among more than two period. Okay, yes. Now this test suggested that the index number should work in a circular manner. The index number should work in a circular manner. What is a circular manner? Okay, so this is like this. Okay, suppose there are three period, you have a data for three period. Okay, you take first period as A, second period as B, and third period as C. So PAB, the price index number between A and B, multiply by the price index number between B and C, multiply by price index number between A and C. Cross multiplication or cross valuation. Okay, so it should get 1, and A is not is equal to B is not is equal to, so that means A, B, C are three different period. Okay, and if you're finding out the price index number among these three time pairs, okay, AB, BC and AC. Okay, and if you multiply all this index number, you should get 1. If it is satisfied, then if it is okay, then your index number is satisfied the circular test. Okay, now we can check whether the last pair index number is satisfied, whether it is satisfying circular test or not. Okay, so as you know that this is the price index number for the period 1 keeping 0 as the base. Now what is P12? Price index number for the period 2 keeping 1 as base into P20. What is that? Price index number for the period 0 keeping 2 as base. Okay, so all combinations are taken, you should get 1. Okay, so look at this is okay, no? P1 Q0, here this is the weight, here this is the weight. Q1 is the weight, here Q2 is the weight. There are three different base period. We have taken three different weights. Now you look at this is P1, this is P2, and this is P0. Here P0, P1, and P2. That means we have checked different combinations. Okay, and if you multiply all these different price index number, here we are having three period, that's why we are having three index number. Okay, so if you are having five period, then we will have five index number. Okay, you multiply all, you should get one. Okay, but as per circular test, a last pair index is not satisfying this test. Okay, so the thing is that this test is not satisfied by any of the test or any of the weighted aggregate formula. Okay, we have discussed many weighted index number method like starting from last pair to Kelly. None of these method are satisfied this circular test. Okay, and the thing is that for satisfying the circular test, there's a condition. The condition is the weight should be fixed. Okay, if the weights are changing from one period to another, such kind of a test will not satisfy the circular test. Okay, so the condition is the weight should be fixed. Okay, so fixed weight index number, the Kelly's index number is based on a fixed index number method. Okay, so all other methods are changing weighting index number or changing weights index number. Okay, but Kelly's method is based on fixed base method. That's why Kelly's fixed base index number method is satisfying this circular test. Similarly, simple geometric mean of the price relative method, that is, this is not weighted. Okay, unweighted simple geometric mean of the price relative method is also satisfying this test. Okay, so that's all about. Now, if you look at the Kelly index, we can check Kelly index number. Okay, P01, P12, P20. Okay, what's the peculiarity of this Kelly's index number? Kellys are assigning a weight in all period. Okay, by taking a combination of different weights, and these weights are fixed for all. It may take between two period or more than two period. No problem. It may take a geometric average or arithmetic average, no problem. But the thing is that Kelly's weight is fixed. Okay, so sigma P1W divided by sigma P0W. Look at this, W, W, W. Since this W is constant, okay, then if you multiply all these P1, P2, P0 divided by P0, P1, P2, numerator are exactly balanced in the denominator, so you may get a value 1. Okay, and that's why we are saying that Kelly's index number is satisfying the circular test. Okay, yes, so we will give you the problems to solve later. Okay, so in this lecture we discussed some ideas. First idea is we have a lots of index. We have learned a large number of different index number, weighted, unweighted. Okay, price relative method, aggregate price index number method, many methods. Okay, but the question arises, which method is better method? In order to answer for this question, okay, different statisticians have developed different tests. Okay, and all these tests are just checking the adequacy of an index number. First index number, unit index number. What is a unit test? What is the unit test? Whatever may be your unit of measurement, whatever may be the prices is quoted. Okay, if you calculate the index number, your index number should not be influenced by the unit in which your prices and quantities are quoted. Okay, yes. Second test is time reversal test. It is just checking the time inconsistency of this index number between two different periods. Okay, so in this test, what we are just doing is we are changing the time. Okay, that means we are considering base period and current period. Okay, then in the next time or in the next step, we are considering the earlier base period as current period and the earlier current period as the base period. We are changing the base into current and current into the base, and we are multiplying these two index number, and we should get 1. If you are getting 1, then this test is satisfied. Okay, yes. Third one is the factor reversal test. Here what we are doing, here we are checking your quantity index number multiplied by the price index number is giving your value index number. Okay, that is price multiplied by quantity should give you the value. Okay, so whether it is happening or not, if you are taking price index number and its corresponding quantity index number, then if you multiply both, whether you are getting your value index number or not. Okay, so if you are getting it, then this test is satisfied, factor reversal test is satisfied. If you are not getting, this test is not satisfied. Okay, and the last pair of past test index number are not satisfied in this test. This test is satisfied only one index number called Fisher index number. Okay, so Fisher index number is the only index number, or Fisher index number is betterly known as an ideal index number or the best index number. Okay, so why it is called the best index number? Because it is based on, it is considering current year as well as base year quantity as the weight. Second one, it is taking the geometric mean, which is the best average when you are taking when you are finding out the average of an index number. Okay, and the third and most important reason is this test is satisfied time reversal as well as factor reversal test. Okay, and that's why it is known as an ideal index number. Okay, yes. Now the last test, circular test. Okay, this test is a extension of time reversal test. Okay, and this is suggested by Stigott, and it says that the index number should work in a circular manner. That is, if you are having more than two period of data or two period of analysis, okay, then if you change if you consider different combination of base year and current year, and if you multiply all these different combinations, and you should get 1. Okay, yes, and this test is only satisfied by the Kelly's index number as well as geometric average of price relative index number. Okay, so this is all about the test of adequacy of an index number. Okay, so in this class or in this video, I have not shown you any kind of problems. Okay, so in next video I will show you, or I will give you problems. Okay, and you have to check whether this problems is satisfying different tests. Okay, yes. So I hope you enjoy the class. Thank you.